triangle ABC has AB equal to 9, and the ratio of BC over AC is equal to 40 over 41. What's the largest area that this triangle can have? So let's draw a triangle. We will label this A, this vertice B, and that vertice C. AB is 9, and the ratio of BC over AC is 40 over 41. So I will let BC equal 40x, and I will let AC equal 41x. So the area of this triangle can be calculated using Heron's formula. And Heron's formula states that if you have a triangle with the sides ABC, the area can be calculated entirely with just those side lengths. And it is calculated as follows. The square root of s times s minus a times s minus b times s minus c, where s is half of the perimeter. So it's a plus b plus c divided by 2. So we will use Heron's formula to calculate the area of our triangle ABC. So the area will be the square root of, first and foremost, s, which in our case would be 9 plus 41x plus 40x, which is 9 plus 81x all over 2. This is our s. And then from this we have to now calculate s minus a. 9 plus 81x over 2 minus a, and I will let a be 9. And then s minus b, so again 9 plus 81x over 2 minus b, and I'll let b be 40x. And then finally s minus c, which is 9 plus 81x over 2 minus 41x. And that's all under the square root sign. So this is the formula that we are going to deal with. Now let's simplify this. We will have 9 plus 81x over 2, and this one becomes 9 plus 81x minus 18 over 2. This is 9 plus 81x minus 80x over 2, and this is 9 plus 81x minus 82x over 2. And this is all under the square root sign. Now, this 2, this 2, this 2, and this 2 all combined is 16. I can kick that out of the square root, and it becomes 1 over 4 when you take the square root. And then under the square root sign, we are left with just 81x plus 9 times 81x minus 9 times 9 minus x times 9 plus x. And then what we can do, as you can clearly see, is we can now combine these. This becomes 81 squared x squared minus 81, and this one becomes 81 minus x squared. And then at this point we can manipulate this a little bit because it will help us in the next step. So at this point we can factor out an 81, and if we do, we're left with 81x squared minus 1, and this one just remains 81 minus x squared. And we can combine this with that. So this one becomes 81x squared minus 1, but then these two combine to give you 81 squared minus 81x squared, like this. And the reason for doing that will become clear in the next step. And the next step is as follows. At this point, you will use something known as AMGM. And that refers to arithmetic mean, geometric mean. AIME states that if you have any two numbers, say a plus b, and you take their arithmetic mean, which is of course just a plus b divided by 2, it will always be greater than or equal to the geometric mean of those same two numbers, and the geometric mean is a times b under the square root sign. This always holds true. So we use AIME on this equation right here. And how do we do that? Well, we recognize that this can represent our A right here, and this can represent our B, which is right here. And then we can utilize that to create this inequality as follows. 81x squared minus 1 times 81 squared minus 81x squared, all under the square root sign, will be less than or equal to, if this is A and this is B, we add them and we divide by 2, exactly like AIME states. So it would be 81x squared minus 1 plus 81 squared minus 81x squared, all over 2. And when you do that, you notice that the 81x squareds cancel, and we are just left with 81 squared minus 1 over 2. And that is greater than this part of the inequality. And now 81 squared minus 1, all divided by 2, if I put a 1/4 in front of it and another 1/4 in front of this, this now represents our area. It's exactly the same as what we had up there. So that means instead of this long expression, I can just put area. And if it was area of ABC. And it's going to be less than or equal to 1/4 times 81 squared minus 1 over 2. And 81 squared minus 1 is 6560. And of course we got to divide by 2 and then later multiply it by 1/4. And this number divided by 2 is 3280, and then divide by 4 and you get 820. And this is the area of ABC. So the area of ABC is less than or equal to 820. So the maximum area for ABC is 820. And that is exactly what they wanted us to find out. What is the largest area that this triangle, triangle ABC, can have?